Dear students, hope you are all doing great. So Mary's is coming up with a new kind of course and introducing with the help of modules and all, and as part of the module 1 I am going to deal with the operating system subject. So before we move on to the things, let's discuss the contents, the syllabus, what we are going to discuss. Now, okay, so these are the contents we are going to discuss as part of the syllabus. So operating system teaching schedule, the first I will start with the introduction and background. So in the introduction and background, I will just roughly go through what is operating system and the types of operating system and goals of operating system. So most of you generally already studied operating system. You might be aware of all these things. By considering all variety of the students, there may be some freshers who are studying first time. So I am going to start with the introduction and background. We'll just roughly, I will give you the idea what is operating system, types of operating system, goals of operating system and all. And the later we will enter into process management. Remember the actual GATE syllabus starts from process management. So in the process management, I will discuss process concept. I will discuss the process concept. Okay, like what is the meaning of process? How do you define the process? What are the states of the process? Okay, we are going to study in detail all the concepts related to process. And next, we will enter into CPU scheduling. So in the CPU scheduling, we are going to study various CPU scheduling algorithms. The extensive CPU scheduling algorithms, will study around 10-11 CPU scheduling algorithms with all variety of questions. And the next we will discuss synchronization, and the next is concurrent programming, and next deadlocks and threads. Okay, so please copy all the contents, whatever I am discussing, you can please pause the video and copy all this. Okay, and next, so these are the contents related to process management. In the process management, okay, most of the time CPU scheduling, synchronization, these are the more important. 40% questions will come from these two areas, CPU scheduling and synchronization. So what does that mean? It means almost every year in the GATE exam there will be definitely a question from CPU scheduling and also from synchronization. If you observe from last previous 4 to 5 year consecutive papers, so definitely there is a question from CPU scheduling and also from synchronization. Okay, and next, so next we will move on to the next topic, that is memory management. So memory management, okay, because of space issues I did not write completely, so hope you can understand. So memory management, memory means I am talking about main memory. So that is your RAM. Okay, I am talking about main memory. So next we are going to study, in this we are going to study RAM chip implementation. It means how your main memory is organized, how main memory is implemented by using RAM chips. And the next we will discuss okay, memory management techniques, and in between we will study some more topic, some small theoretical topic, that is loading, okay, linking and address binding. No need to write, okay, anyway I will discuss. So this is a small topic, so I did not write. So if you want you can write down. So that is loading, linking and address binding, some theoretical topic. And next we will study the important aspect in the memory, okay, that is memory management techniques. So in the memory management techniques we are going to study, okay, paging, multi-level paging and inverted paging, segmentation and segmented paging. So each and every memory management technique I will explain complete in detail. So what is the need of paging, why we are going for paging, what is the purpose of paging, and in-depth concepts, and as well as okay, including all variety of problems, including all your previous GATE questions. Okay, and next multi-level paging, why we go for multi-level paging, what is the advantages, okay, what is the purpose of multi-level paging and how it is implemented, and all variety of concept and including all variety of problems. And remember, including all previous GATE questions, important previous GATE questions also I will discuss in the classroom only. And the next inverted paging, segmentation and segmented paging. And next in the memory we are going to study, next one is the virtual memory. So I think most of you are heard about the term about virtual memory. I'll discuss complete in detail. Okay, I'll discuss around 3 to 4 hours what is the purpose of virtual memory. Okay, and most of in all our modern operating systems, in all our computers what we are using, we use the concept of virtual memory. So what is the purpose of virtual memory and what happens if you remove the virtual memory, and all okay concepts and also problems I'll discuss in the class. And the next okay, after that we are going to study file systems. It means okay, how the files will be organized, directory structure and the disk structure, and we are going to have the disk space allocation techniques, some important things okay in the file systems also. So this is the syllabus okay, as part of the GATE examination concern. And remember, there are some important rules and instructions you need to follow okay, with respect to the course concern. Remember, okay, I am assuming all of you are very serious okay, with respect to the subject and learning with the utmost sincerity and dedication. And when you are attending my class, it is not like okay, you are watching some YouTube video. It is not like this. Okay, you have to take with the proper notes and proper pen and multiple color pens if you want, and make a proper notes when I am explaining each and everything. And remember, there are so many important points coming up, there are so many definitions coming up, and I am not going to write everything on the board. I will make the dictation. So it is just like a regular class. It is just like a regular class. We want to give complete in-depth. What I am going to teach in the classroom, I am going to give in the online. Okay. So maybe because of this COVID situation, okay, we are coming with the online support, and we want to give okay, we want to benefit the more students. So we are coming with this okay, with this kind of course. So it is you have to study with utmost sincerity and dedication and with hard work. Okay, with proper notes and pen when you are attending the class. So if anybody not copied, okay, you can just pause my video and just make a note of all the contents. So hope okay, contents are visible. Okay, now understand here. So 40% questions I said okay, in the process management, 40% questions will come from these two areas, and the next 40% questions will come from memory management techniques and virtual memory. So I write here the next 40% questions will come from these two areas. So that is memory management techniques and virtual memory. And remember, whatever the 40% and 40% I am writing, that is based on previous GATE questions analysis, based on the previous GATE question papers analysis, and the remaining 20% can be from anywhere. It can be from anywhere. Okay. So that is about the syllabus. Next, now coming to the important instructions. Remember, okay, with the course we are providing the workbook. Okay, I think all of you having this workbook. You can see this GATE 2021 okay, workbook. Okay, this mix of 3 subjects: computer networks, DBMS and operating system. So you need to carry this workbook okay, along when you are sitting, when you are attending the class. So carry this workbook along with you, because in between whenever I discuss, I will directly solve the questions from the workbook. So why I am saying this? Because I will not write the question on the board. I will not write the question on the board. I will simply say go to this page number and we are going to discuss that particular question. Okay, I will solve the question directly here. Okay, so carry this workbook. And the next, now there are some important points. Okay, the first thing is I said workbook. You have to carry the workbook along with you. And the next important thing, understand here, most of you, okay, you are already preparing for the GATE examination. I think you already studied operating system in your colleges. So you may study operating system as a theoretical subject. So generally the most of the engineering colleges, okay, you study operating system as a theoretical subject. Generally students will feel like that, okay, because in the exam you write something in the papers and you fill the papers and you get the marks. But remember, that is not going to be okay, fact with respect to GATE examination. With respect to GATE exam, operating system is purely logical, numerical and concept oriented subject. Okay, I am repeating once again. Operating system is purely logical. It is purely logical subject, concept oriented and numerical based subject. Okay, so you will experience in the class how logical it is and how concept oriented. Okay, you will understand all that. Okay, in the classroom. Okay, So okay, please remove that mind, okay, from that from your mind, because generally you feel it as a theoretical subject. That is not at all true with respect to GATE exam. Okay, and the next important point, listen carefully. In my class, I will explain the concept in detail, and after that I will make you to solve the GATE questions. It means all the important GATE questions, all from last 10 to 15 years important GATE questions, whatever is there, I will try to discuss them in the classroom only. It means I will explain the concept and I will practice 2-3 questions, and immediately I will make you to solve the GATE question. So you can easily visualize, you can easily understand yourself what I am teaching, how much you are understanding, and what is asking in the GATE examination, and everything will be cleared, okay, in the online class itself, in the class itself. It means, okay, you can clearly understand what I am teaching and what you are understanding and what is asking in the GATE exam. You are able to solve or not able to solve, everything will be clarified in the classroom itself. And remember one more important point, this is a complete power pack course, okay. It is not like okay, something we are explaining and you need to refer some other notes, okay, you need to refer some other textbook, or you need to refer some other, okay, online video. Nothing is required, nothing is required. I am repeating once again, nothing is required. Blindly follow my class, sincerely follow my class. I will solve the complete workbook, okay. In this there are so many chapters are there, so many questions are there, okay. I will discuss all the important questions, whatever the doubts you have I will discuss in the classroom. You are going to solve the complete workbook, and all important GATE questions I will solve in the classroom only. So it means, what I am trying to say, you don't need to refer any outside material, any YouTube video or any online source, nothing is required, okay. Remember, if you refer multiple sources unnecessary, okay, your time will waste. So you are learning, okay, from the experts, okay. Just blindly follow the class and you will directly solve all the previous GATE questions by yourself. If you have a simple, okay, basic understanding of the concept and you have logical skills, okay, you can easily understand, you can solve all the questions by yourself. So that is my confidence. So 90 to 95% of the questions you can directly solve with our class, okay. Remaining 5% obviously they will have some logic, some concept, okay. You need to have much more logical skills, okay, required to solve that questions, right. So coming to the textbooks, okay, most of you are aware of the textbooks. So anyway, I will give the textbooks also, okay. So coming to the textbooks, okay, anyway I am just giving for the reference, okay. So because you should aware of the textbooks. So the first textbook is Operating System by Silberstadt Galvin. So this is the first textbook, okay, you need to refer, okay. I think most of you studied the same book. I think it's like a pink color pad with dinosaurs on it, okay, maybe if you remember. And the next second textbook is Modern Operating System by A.S. Tenenbaum, Andrew S. Tenenbaum. That's the second textbook. And third textbook, okay, so I write here. So the third textbook will be Operating System by William Stallings. Operating System by William Stallings, okay. So these are the standard books, 3 standard books, okay, generally I suggest to the students, okay. So remember, okay, different topic is good in the different textbook. Different topic is good in the different textbook. I will clearly tell you, okay, which topic is good in the which textbook, okay. If you have any doubt when I am discussing the concept, I will clearly tell you, okay, for this topic you need to refer this textbook, okay. In the class I will clearly mention. And the next, okay, if you are having any, okay, little bit doubt, okay, after listening my class, okay, then you can refer the standard book, otherwise not required, okay. After just follow my class, after that if any small doubt is there or anything extra required, okay, then you refer the book, otherwise not required. So remember, our class will help you to solve all previous GATE questions. Statement is very clear. If you want to study anything extra, then you can refer the textbook, okay. That is your wish. But remember, if you are having any doubt, refer only standard textbook. Okay, don't go for any online Facebook group or maybe in the YouTube channels and all that. So unnecessary waste of time. So these days, okay, with my experience, I am telling you, okay, students will ask some kind of doubt. Okay, I'll ask them like, where you get the doubt? Okay, where you got this doubt? Okay, so you'll say, okay, some Facebook group he is getting some question. Remember, you should have some smart things, okay, smart techniques to study, where to study, what not to study. Okay, if somebody is posting some question in the Facebook, okay, and you are a Facebook group, you keep on, okay, searching that. Okay, so they don't know what is actual concept. Okay, some question they will post and keep on discussing, waste of time. So these days, students are not having any doubt in the gate question. Students are having doubt in the normal outside questions. So why you refer that? Not required. So I am giving the sufficient sources. Workbook is there, and theory book will be given out. Theory book will also given to you. And I don't know about the previous gate questions. Made Easy will provide, okay, complete gate previous solved book. Okay, we'll have a very mota book hoga. Okay, very gate previous solved book. Okay, around 450. I don't know how much is the cost. I don't know whether it will be given to you, okay, with respect to this course or not. Otherwise, you have to buy. Okay, so maybe, so you can solve all the previous, all subjects, previous gate solved paper will be, book will be there. You can buy that book. Okay, right. So that is about okay, this introduction of the, okay, textbooks and all that. So you need to solve all the workbook and previous gate questions along with the, okay, contents. So once one topic is completed, okay, just open the workbook and solve all the questions related to that particular topic and solve all the previous gate questions also, right? So we follow that kind of strategy. And coming to the marks, okay, if anybody is having doubt, so in the gate exam, so marks will be, okay, for operating system, okay, average marks will be, it will be around 8 to 10. Okay, so this is just an average. Average will say something like, okay, 9 marks or 10 marks you will get. And remember, lower bound and upper bound will change. There is no specific number of marks in any subject. Okay, there is no compulsory, okay, this many marks, okay, compulsory will be given from operating system. No, that is not there. Okay, it will vary. Okay, so on an average, okay, based on the experience what we have, okay, we'll have around 10 marks. But remember, sometimes we are having upper bound of 16 marks, okay, only from operating system, lower bound of 6 marks, okay, from operating system. So lower bound and upper bound will change. Sometimes we get 16 marks, sometimes we get 6 marks. So average I am writing around 10 marks, you can say that. So easily you can score, and the subject is very good and interesting. So that is about okay, marks. And next, so coming to the my introduction. So I think all of you already, when you registered the module, I think you might have seen my name, okay, operating system by Balakrishna sir. So okay, right, so let me introduce myself. So my name is Balakrishna Virala. So generally students call me Bala sir, okay, some students call me Krishna sir, okay, otherwise you can call me operating system sir. Okay, fine, that is fine. OS01 sir, right? So anything is fine. Okay, so you can call me Bala sir, the simple and good. And coming to my experience, okay, I started my career first starting in a software company somewhere in Bangalore in 2007. Okay, right? So after that I shifted to Hyderabad. I worked in IT industry around 6 years. So when I shifted to Hyderabad, okay, coming from Bangalore to Hyderabad, so from Hyderabad based company, I worked in various countries. I worked in London for 1 year. I worked in United States for 1 year. I worked in China for 6 months. So almost throughout the globe, okay, almost around 60-50 around the international trips. Okay, so I had working experience in United States, working experience in okay, UK and China and Hyderabad, Bangalore, in all the places. After that, okay, after coming out of the IT industry, I decided to move on to the teaching side. So I resigned my software job, and I'm completely dedicating my time only with the Made Easy now. So I teach operating system and also the data structures, but maybe for you, so now only operating system I am going to deal with. Okay, right. So you're going to enjoy the course. So be happy and always maintain smile when you're watching the videos, and keep learning and keep smiling. Okay, so hope this is clear. So next video we will enter into the actual subjects. Thank you. And next small thing I want to convey, if you are having any doubts, If you are having any doubts while watching the videos, you can reach on my email. Okay, so I'll give my email also. So because the main problem is communication. If it is a physical class, offline class, I can directly see your faces, okay, and you can come directly to me and ask the doubts. But maybe fortunate or unfortunate, because of this COVID, I am not able to see your faces, because our classroom will be filled of completely students with the smiley faces. So I am missing all that environment here. But anyway, hopefully, okay, so let's see in the future, okay, I will connect with you. So if you are having any kind of doubts, okay, any maybe question or any conceptual doubt, okay, most probably you will not have any career related doubts. So I told you already, okay, my experience, okay, I worked in IT industry, okay, around 7 years, and next completely teaching experience around 10 years. From last 10 years I am in the MedEasy. So I have experience towards the industry side, I have experience towards the teaching side. So if you are having any kind of questions, especially related to career, like career doubts, okay, what you have to do, whether to go for MTech, whether to go for okay IIT MTech, okay, what about MS, what about software job, what about abroad PhD, Indian PhD, okay, any kind of doubt related to career, okay, कौन सा कोर्स सीखना है, कहाँ से सीखना है, क्या करना है, okay, so MTech के बाद क्या करना है, okay, multiple jobs है तो कौन सा job लेना है. So any kind of career related doubts, okay, you can ask me. So I am not saying, okay, I know everything. I am not saying I know everything. So I have a friends in every area, almost in every area. I have a friends, and all your seniors, like those who have passed out from the MedEasy, they are in a very good companies. Okay, so at least I will connect with the right person. I will connect with the right person. I will give their contact number or a mail ID, so you can directly talk to them. Okay, so I am not saying I know everything. So I can connect with the right person, so that you will get the proper guidance. Okay, so what you want to learn. Right, so I'll give my mail ID. You can just make a note of it. So this is my mail ID. So Balakrishna dot Virala, VEERALA @gmail.com. So all are small letters only. Okay, just for easy understanding, I am writing the capital letters. So BALAKRISHNA, balakrishna.virala@gmail.com. So okay, if you guys are in the Facebook, you can like my Facebook page. So just for any references, the Facebook page. So same thing, Balakrishna Virala CS. Okay, CS. Okay, CS means computer science. Okay, right. Okay, so Balakrishna Virala CS, that is a Facebook page. You can like my page. Okay, you cannot send Facebook friend request because it is already full. Okay, Facebook accepts maximum 5,000, so it's already full 5 years back. So you can please like my page and you can be in touch with me. Okay, so that is about introduction. So hope the things are clear. So be sincere while learning the classes. That's my suggestion, and you can easily score good marks with respect to this subject. So next we will move on to introduction and background. So in the introduction and background, we will just roughly understand what is operating system, some simple basics. So most of you already studied, but just for overview purpose, I am going to discuss all that. Okay, because in computer science generally you have other branch students also. Okay, mechanical students will also appear computer science, electrical electronic students also will appear computer science. Okay, so we need to consider all kind of category of students. So generally the people say CS means not computer science, CS means common sense. Okay, so anyone can understand and write the GATE exam through computer science. Okay, so most of the time, okay, almost in the top 20 ranks, okay, there will be definitely some other branch students will be there. Most of the time All India first rank also, mechanical student got All India first rank in computer science. Okay, right. So they study mechanical in BTech and write the exam in computer science. Okay, so I consider all that, so don't worry. So come back to this in the introduction and background. So I'll just go through what is operating system, types of operating system and all that. So let's see, how do you define operating system? What is an operating system? How do you define operating system? Now it's a simple definition, generally most of you already studied. Okay, what is operating system? Simple definition. Okay, operating system is an interface between user and computer hardware. computer hardware. Okay, user and computer hardware. Okay, now understand here. So that is a simple definition of the operating system. Okay, make a proper notes while listening. Okay, make a notes. Okay, operating system is the interface between user and computer hardware. What is the it means? Okay, user and computer hardware. Okay, it is an interface. Interface means what? Mediator. Simple. Interface means what? Mediator. Okay, based on this diagram, I want to write. So diagram. I want to draw the diagram here. Okay, let's say here comes computer hardware. Okay, here comes computer hardware, and next in between comes operating system, and the next here is user applications, and here comes user. Let's say user 1, okay, user 2, okay, let's say user 3. Okay, understand the definition properly. Okay, copy this. Right. So operating system is the interface between the user and computer hardware. Okay, user in the sense what? User application. Understand? User application. It means what? Any of the user application wants to interact with the computer hardware. Okay, once to interact with the computer hardware, it will make use of what? Operating system in between. So what is a user application? So which is called as a user application generally? Which is called user application? Okay, if you are writing any Java program, that is a user application. You are writing any C language program, that is a user application. Yes or no? Right? So if you are writing any C language program, that is a user application. A very big C program you have written. You have written a very big Java application, that is a user application. So any of the user application wants to interact with the computer hardware, okay, it will make use of what? Operating system as interface. Interface means what? Mediator. Interface means mediator. So, okay, what is user application? I said any user program, okay, just like C language program. I write a very simple basic C language program. Okay, understand this. Okay, I think already all of you know this. The basic C language program I'm writing. So main, let's say you are having integer x. So let's say you are having something called okay, printf hello. So I'm writing a very basic C language program here. So if I consider this as a user application, I'm writing a simple C language program, nothing is there, okay, integer x and printf hello. Okay, if I consider this as a user application, okay, what is the output you get for this? Output you get is what? Hello. Hello will be printed on the monitor. Everybody knows that. Hello will be printed on the monitor. Everybody knows that. Remember, monitor is a computer hardware. Yes or no? It is printing on the monitor. Monitor is a computer hardware. So it means this program is interacting with the computer hardware because this hello will be printed on the monitor. Now the question is, this simple C language program is interacting with the computer hardware. This hello is printing on the monitor. The question is, how printf is actually recognizing monitor? Question is, how printf is actually recognizing monitor? And remember, I want to read the variable x. I write scanf statement. Let's say scanf, okay, %d, okay, ampersand x. Okay, I want to read variable x. Now tell me what happens if I write the scanf statement. The scanf statement will interact with what? Keyboard. Yes or no? All of you know this already, right? So printf is interacting with the monitor and scanf is interacting with the keyboard. Now the question is, how it is actually recognizing monitor? How it is actually recognizing keyboard? If I ask this question, generally you don't know. You don't know this answer. Why? Because how printf is actually recognizing monitor? If I ask this, okay, you don't know the answer. Why? Because as a programmer, you concentrate more on, okay, more on programming logic, and you don't worry how printf is actually working. What you are doing is, you are simply passing some parameter to the printf. That's all. You are simply passing some parameter to the printf, and that is printing on the monitor. But you don't know how actually printf is working. Now understand how printf is actually recognizing monitor. What happens inside the printf? What is there inside the printf? Now let us see here what happens in the printf. Okay, please copy this. Copy all this. Okay, so printf internally calls. I am writing here printf. Okay, so maybe it's not visible here, so I write here. So printf internally calls. Printf internally calls write system call. Write system call. Write system call. Printf internally calls write system call to communicate with the monitor. To communicate with the monitor. Okay, make a note of this. Anyway, if it is not visible on the board, okay, you can listen my words. Okay, right? So I am repeating whatever I am writing, I am going to repeat. So make a note of this. So what happens? Printf internally calls write system call, okay, to communicate with the monitor. It means what? Understand here. In this statement, whatever the statement I have written, I am using a word called system call. Listen carefully. I am using a word called system call. Printf internally calls what? Write system call to communicate with the monitor. I wrote this. What is the meaning of system call? First of all, I am writing a word called system call. Make a note of a definition. Keep the heading system call. Keep the heading system call. What is the meaning of system call? System call is a request made by user program to the operating system in order to get any kind of service. In order to get any kind of service. Okay, understand the definition properly. So system call is a request made by user program to the operating system in order to get any kind of service. It means what? It means if the user program requires any kind of service from the operating system, internally it will make use of what? System calls. Internally it will make use of what? System calls here. So here printf requires to interact with what? Monitor. So inside the printf, which system call it is using here? Write system call it is using. So it means what? For different kind of services, there are different kind of system calls. Different kind of services, there are different kind of system calls. Is that clear? Now you have a question. How these system calls are written? Remember, system calls are written by using embedded programming. And if you want to know what is the code inside the printf, okay, printf के अंदर function जो define किया, printf के अंदर क्या code दिया गया, this is also a function, right? Printf is what? It is a function only, right? What is the code inside the printf? Printf के अंदर क्या code है, वो कहाँ पे देख सकते हैं? Where you can see that you can see in the header file, stdio.h header file. If you open that header file, you can see what is the code written inside the printf function. Okay, so you don't require all that. Okay, that is not required. So that is all called as what? Abstraction. If you observe the OOPS concept, we call that as abstraction, because you are simply hiding non-useful data from the common user. That is called as abstraction. So what is there inside the printf and all that? Not required. Okay, so but as for operating system concern, you should know. Now if somebody is asking what is operating system, simple definition, right? What is operating system? Okay, you can simply say it is the interface between user and computer hardware. Remember, instead of saying simply it is the interface between user and computer hardware, you have to say clearly it is working as interface between user and computer hardware internally with the help of system calls. For every service, okay, whatever the user program requires, internally everything is what? System call only. How these system calls are developed? By using embedded programming. Is that clear? So that is a different story, not required for us. Okay, this is a simple definition of the operating system. And the next, operating system is also called as the next definition. Okay, make a note of it. Operating system is also called as resource allocator. Operating system is also called as a resource allocator. Is also called as resource allocator. It means what? Okay, understand here. Operating system is also called as resource allocator because it is responsible of allocating resources of a computer. Whatever the resources we are having in the computer, operating system is responsible of allocating resources of a computer. What are the resources we have? Okay, note down this. Resources are categorized into two types. One is hardware type of resource and next is software type of resource. Okay, one is a hardware type of resource and next is a software type of resource. Hardware type of resource example is what? Memory. So memory is a hardware resource and next is what? Devices. So these are the hardware type of resources. And software type of resources example will be what? Files and next directories. files and directories. Okay. So hardware type of resource example is what? Main memory. Memory in the sense what? It can be any kind of memory, right? So main memory is also managed and allocated with the operating system, and even secondary memory also, RAM also, everything is managed by the operating system only, right? Devices means what? All your printer, scanner, monitor, everything is managed with the operating system only, right? So software type of resource will be what? Files and directories. Directories in the sense what? Folders. Okay, all your file management, all that, everything will be managed with what? Operating system only, right? Right. So that is about a resource allocator. So this is the simple definition of the operating system. Next. So next, understand what is the goal of operating system. Note down. Next, goals of operating system. Goals of operating system. So goals of operating system in the sense what? Okay, when you are designing the operating system, what must be the goal of operating system? So what should be the purpose? So understand here, goal of the operating system, the primary goal of the operating system, the primary goal is convenience. Convenience. Okay, and next the secondary goal of the operating system, the secondary goal is efficiency. Efficiency. Understand here. So this is the goals of operation. It means what? Primary goal is what? Convenience. Convenience मतलब क्या होता है? Convenience means what? Okay, easy to use. Simple, easy to use. Okay, simple meaning. And next, the secondary goal is what? Efficiency. Efficiency means what? Okay, I write here stability. How stable the operating system is. Okay, stability. Simple meaning I am writing. Okay. Now remember, the primary goal and secondary goal, it will change from operating system to operating system. Like example, if you observe the Windows operating system, Windows is designed with the primary goal as what? Convenience. Why? Because anybody who understands simple English can easily work on Windows operating system. Yes or no, right? So anybody who understands simple English can easily work on Windows operating system. So Windows is designed with the primary goal as what? Convenience, and secondary goal as what? Efficiency. And whereas if you observe the Unix operating system, Unix is designed with the primary goal as what? Efficiency, and secondary goal as what? Convenience. Why? Because anybody who knows simple English cannot work on Unix operating system. If you know simple English, you cannot work on Unix operating system. If you want to work on Unix operating system, you should know the specific commands. Okay, for every operation there is a command. You should know the specific command, then only you can work on Unix operating system. So what I am trying to say is, okay, for operating system, the primary goal and secondary goal will change. And remember, here we are not talking with respect to any particular operating system. We are not talking with respect to any particular operating system. And remember, these are the general goals of operating system. General goals of operating system. So if somebody is asking what is the primary goal of operating system, so you have to say what? Convenience. If somebody asking what is the secondary goal, okay, you have to say efficiency. Okay, so in general, remember our course is general concepts of operating system. We are not talking about with respect to Windows or with respect to Unix. Okay, general concepts of OS. So that is okay, goals of operating system. So next we will move on to the next one, that is types of operating system. So what are the various types of operating systems we have? So this is as part of our introduction. So let's see types of operating system. So just for easy understanding, I am just going through the background story and all that. So let's see what is the types of operating system. So note down, make a notes of this, types of operating system. So the first type of operating system we had is the batch operating system. The first type of operating system we have is a batch operating system. Okay, understand here. So batch operating system, batch means what? You can easily understand. Batch means what? Group. Okay, you say now this is the batch of 2021 gate. So batch in the sense what? Group. Okay, right. So in the batch operating system, so what used to be? Okay, look at here. So just copy this diagram. Copy the diagram. So in the batch operating system, multiple jobs will be loaded onto the memory. So like job 1, job 2, job 3, job 4, like this. And we are having the CPU here. Let's say we are having IO devices. Okay, just copy this diagram. Copy the diagram. Now the batch operating system. So I am coming. Okay, understand here. So batch means what? A group of jobs. Okay, listen here. So group of jobs, group of similar kind of jobs will be loaded onto the memory. Group of similar kind of jobs will be loaded onto memory. Remember, memory means what? Which memory I am talking about? Main memory. I am talking about main memory. I think you study computer organization, you study von Neumann architecture and all that. So don't worry, you will understand all that. So when I say memory here, I am talking about main memory. So group of similar kind of jobs will be loaded onto memory, and here is the operating system. The responsibility of the operating system is to schedule the job onto the CPU. Understand here. So CPU is what? It's a machine. Okay, CPU is a machine. Okay, right? So responsibility of the operating system is what? To schedule the job onto the CPU. Okay. Now let us say we are scheduling some job onto the CPU. Let us say job 1. Job 1 we schedule onto the CPU. Now remember, when you schedule job 1 onto the CPU, so it is keep on executing the instructions on the CPU. Remember, in order to complete any kind of job, the job generally requires 2 different times. Okay, note down. Copy this. Time is categorized 2 types. One is CPU time and the next is IO time. One is the CPU time and next is what? IO time. Time is categorized 2 types, CPU time and IO time. Now what happens in the CPU time and IO time? Okay, listen carefully. So it's a general, okay, you can understand easily. In the CPU time, what happens? In the CPU time, you execute the instructions on the processor. Okay, you execute some instruction, you are doing any calculation. So that will be done in the CPU time. In the IO time, what happens? You will perform what? IO operation. What is called as IO operation? You are reading any input from the keyboard like scanf statement. That is the IO operation. You are reading any file from the hard disk. Okay, hard disk में से कोई फाइल को आप लोड कर रहे हैं. Like for example, you have written a file programming. आप लोग C language में file programming करते. Okay, maybe somebody has done, somebody has not done. So in the file programming, you write something called fopen, fclose. Okay, right. So in that you write the name of the file and in which mode you are opening the file. It means what? Your C program is reading the file from the hard disk. So that is all called as what? IO operation. Okay, right. So time is categorized what? 2 types, CPU time and IO time. In the CPU time you execute instructions on the processor, and in the IO time you perform what? IO operation. Next, now come back to this. Okay, that you should remember. Next, come back to this. Okay, now we are having operating system here and memory here. Responsibility of the OS is to schedule the job onto CPU. Now we schedule the job onto the CPU here. After executing some amount of time on the CPU, it will execute which time? On the CPU, it will execute CPU time or IO time? CPU time, executing some calculations and all that. Okay, performing CPU time. After executing some amount of CPU time, if the job 1 requires any IO operation, like for example, okay, it is performing any scanf statement आ गया. Scanf statement आ गया तो क्या होगा? Obviously it requires input output, user का control में जाएगा. Scanf मतलब आपको input देना पड़ेगा keyboard से, exactly. So if it requires any IO operation, then what happens? Okay, it will leave the CPU. Okay, note down, copy this. Okay, if it requires an IO request, what happens? It will leave the CPU, move on to the IO devices to perform IO operation. Okay, so it will leave the CPU, move on to the IO devices to perform IO operation. Okay, now what happens here when the job 1? Okay, make a note of this. Okay, if you are if I am fast, you can simply pause the video and okay, you can make a note of this. Right. So when the job 1 is leaving the CPU to perform IO operation. Okay, if the job 1 requires IO operation, what is happening here? It is leaving the CPU, move on to the IO devices to perform IO operation. So when the job 1 is leaving the CPU, what is happening here? The CPU is becoming what? Idle. Remember, okay, when the CPU becomes idle, even though we are having another job, we are not going to schedule that onto the CPU. Even though we are not having another job, we are not going to schedule another job, because in the batch operating system, that is a very old operating system. In the batch operating system, they follow the strategy that if the job is completed completely, then only another job will be scheduled onto the CPU. Okay, so I am writing here, if the job is completed completely. So I write here, okay, the first point, if the job is, note down, if the job is completed completely, then only another job will be scheduled onto the CPU. If the job is completed completely, okay, then only another job will be scheduled onto the CPU. Now understand here, okay, so I am writing something called if the job is completed completely. इसका मतलब क्या होता है? If the job is completed completely, then only another job will be scheduled. What is the meaning of completed completely? Including CPU time and also what? IO time. If the job is completed totally, then only you schedule what? Another job. So if that is the case, अगर आप ऐसा कर रहे हैं तो क्या होगा? Look at here. When the job is leaving the CPU to perform IO operation, what is happening here? CPU is becoming unnecessary idle. Even though you are having another job, you are not going to schedule that onto CPU, because what is the strategy you are following in this operating system? If the job is completed completely, then only you schedule another job onto CPU. Remember, if you follow this kind of principle, if you follow this kind of strategy, what is the problem? CPU is becoming idle for more amount of time. CPU is becoming idle for more amount of time. So what is the problem here? Next, second point, note down, increased CPU idleness. Increased CPU idleness. Okay, next point, increased CPU idleness. It means what? CPU is idle for more amount of time. CPU बहुत देर idle हो रहा है. CPU is idle for more amount of time. Remember, if the CPU is idle for more amount of time, then what is the effect of that? Okay, उससे क्या हो जाएगा? Efficiency will decrease. Okay, throughput of the system will decrease. Okay, understand here? What's the problem? Note down. Next point, decreased throughput of the system. Decreased throughput of the system. Decreased throughput of the system. Understand here? So increase the CPU idleness. So CPU is idle for more amount of time. If the CPU is idle for more amount of time, what is the effect of that? Throughput of the system will decrease. So what is the meaning of throughput? So I am writing a word called throughput. What is the meaning of throughput? Note down. Definition of the throughput. Keep the heading throughput. Okay, throughput means number of jobs. Note down. Number of jobs completed for unit time. Number of jobs completed for unit time is called as the throughput of the system. Okay, understand here? So number of jobs completed for unit time. Unit time means what? Per second. Okay, unit time means what? Per second. Okay, so obviously if the CPU is idle for more amount of time, obviously effect will be what? Throughput of the system will decrease. Okay, so this is the batch operating system. Remember, this is very outdated operating system, very old operating system, nobody is using. If you want example for this, okay, just for reference, if you want example for this, example is IBM OS by 2. So this is the name of the operating system, very old and outdated operating system. Okay, just make a note of it. Example for this batch operating system is IBM OS by 2. Okay. So that is the basic problem. Okay, what is the major problem in this? CPU idleness is high. Increase the CPU idleness. If the CPU idleness is high, obviously throughput of the system will decrease. Okay, so that is example is IBM OS by 2. So that is the batch operating system. The next, so next we'll move on to the next type of operating system. Next type of operating system, that is multi-programming operating system. Note down. Multi-programming operating system. Next is multi-programming operating system. Now what is happening in the multi-programming operating system? Okay, note down, copy the diagram here. So here also we have multiple jobs like job 1, job 2, job 3, job 4, job 5. So the same thing, we are having the CPU here, we are having IO devices. Okay. Now next we will move on to multi-programming operating system. So copy this, you can pause the video and copy this. Okay. Now in the multi-programming operating system also, here also we are having multiple jobs loaded onto the memory here. So same thing, when I say memory here, which memory I am talking about? Main memory. Now remember, in the multi-programming, multiple jobs are loaded, but remember they are not group of jobs. So this time they are individual jobs. Like you are having job 1, job 2, job 3, job 4, job 5, like this. Now same thing, the responsibility of the operating system, responsibility of the OS is to schedule the job onto the CPU. Now let's say we are scheduling some job onto the CPU. Let's say we are scheduling job 2 onto the CPU. Now, okay, some job, okay, so operation will decide which job, okay, you are going to schedule. Now understand, let's say I schedule job 2 onto the CPU here. Now same thing, what I said, in order to complete any kind of job, job generally requires two different times. What is that? CPU time, and next is what? IO time. Now let's say here also you schedule some job onto the CPU here, and the CPU will execute which time here? CPU time. It will execute some instructions, it will make some calculations and all that. After executing some amount of CPU time, if the running job requires any IO operation, then it will leave the CPU. Look at here, if it requires an IO operation, it will leave the CPU, move on to the IO devices to perform IO operation. Okay, because it requires IO operation. Like same example you can say, okay, scanf statement aa gaya, to kya hoga? It will leave the CPU and move on to IO device. Matlab it will wait for the keyboard se input dene ke liye wait karega. So it will leave the CPU and move on to the IO devices, right? And remember, in the multi-programming operating system, what happens is, when the job is leaving the CPU to perform IO operation, we are not going to make the CPU to be idle. Immediately another job which is ready for execution will be scheduled onto the CPU. Another job which is ready for execution, maybe any job, like, okay, so let's say job 4, another job which is ready for execution will be scheduled onto the CPU. Is that clear? So when the job is leaving the CPU to perform IO operation, another job which is ready for execution will be scheduled onto the CPU. So it means what? What we are trying to do? We are trying to increase the CPU utilization. Indirectly, what we are trying to do? We are trying to increase CPU utilization. So if the CPU utilization is increased, so what happens? Obviously, the throughput of the system will increase. If the CPU utilization is increased, obviously what happens? Throughput of the system will increase. Is that clear? So make a note of all the points. Note down the first point. Copy this diagram. A diagram copy kiya sab log. Copy this diagram. Okay. Note down the first point. Okay. If the job is, note down, if the job is leaving the CPU, to perform IO operation, if the job is leaving the CPU to perform IO operation, then another job which is ready for execution, will be scheduled onto the CPU. Another job which is ready for execution will be scheduled onto the CPU. Okay, right. So that is the first point. Now, so because of this, what is the advantage? The next, when the job is leaving the CPU, another job which is ready for execution will be scheduled onto CPU. So what is the advantage of this? Advantage, okay, note down, that is increased CPU idleness. Increased CPU utilization. Okay, so CPU utilization is increased. So obviously if the CPU utilization is increased, so what happens next? Increased throughput of the system. throughput of the system. Okay, right. So increase the CPU utilization. When the CPU utilization is increased, so obviously the throughput of the system will also what increase. Is that clear? So this is multi-programming operating system. So if you want example for this, okay, look at here. So example for this is okay. So all our operating system nowadays, that is Windows, okay, Unix, Linux. In all our operating system nowadays, whatever we use, okay, they are all multi-programming operating system only. So what are the Windows you are using? So all that is a multi-programming operating system. Okay, that is simple. So next, we will move on to the next type of operating system. Next type of operating system, that is multitasking operating system. Multitasking operating system. So keep the heading multitasking operating system and copy this diagram. Copy this diagram. Next, okay, multitasking operation. Just copy this diagram. Okay, note down the first point. First point here. Multitasking is multitasking is an extension of multi-programming operating system. Multitasking is extension of a multi-programming operating system. Note down. Next point. Go. The jobs will be executed. The jobs will be executed in the time sharing mode. The jobs will be executed in the time sharing mode. Okay, right. Now only these 2 points are okay enough. Now understand this, you can easily understand. So first point what you have written, first point is what? Multitasking is a extension. It's just an extension of what? Multi-programming operating system. Just an extension. So multi-program will be there already. Okay, it is an extension of multi-programming operating system. Second point is important. Jobs will be executed in the time sharing mode. What is the meaning of this? Let's say you are having memory here. We are having operating system loaded into the memory, right? I am talking about main memory. Already I told you the multiple jobs are loaded here. Okay, multiple individual jobs are loaded here. Now same thing, responsibility of the operating system is to schedule the job onto CPU. Now what happens here is, okay, jobs will be executed in the time sharing mode. It means what? Okay, you schedule job 2 here. You schedule job 2 here. Job 2 will execute some amount of time. Like example, 2 nanoseconds of time. Just example, 2 nanoseconds. Now after 2 nanoseconds of time here, you are going to okay remove this from the CPU and you schedule another job onto the CPU, like job 1 onto the CPU. Okay, multiple jobs will be sharing the CPU in the time sharing mode. Second point is important. Jobs will be executed in the time sharing mode. It means what? Okay, schedule job 1 here and this will also execute how much time? Same, 2 nanoseconds of time. And once 2 nanoseconds is completed, okay, it will be removed back to the memory and you schedule another job onto the CPU, like job 3 onto the CPU. Okay, so like this, multiple jobs will be sharing the CPU in the time sharing mode. Remember, this is what is actually happening in our operating system. This is what is actually happening in our computer. Why? Because you can imagine job 1, you are listening some song. Okay, koi gana sun raha hai. Job 2, okay, you are writing any C language program. Job 3, okay, you are writing something in the Word. Okay, job 4, you are playing some game. Okay, maybe something, playing some video. What happens is, okay, you schedule your song, execute 2 nanoseconds and back to the memory. Schedule your C language program, execute 2 nanoseconds and back to memory. And schedule your, okay, maybe movie and execute 2 nanoseconds and back to the memory. Like this, multiple jobs will be sharing the CPU in the time sharing mode. Remember, important point, at any point of time, only one job will execute on the CPU. At any point of time, only one job will execute on the CPU. Remember, as a user, okay, as a user, listen to me first, listen to me. As a user, you feel that all the jobs are executing simultaneously because आपका गाना कोई break नहीं हो रहा है. Remember, when you are playing any song, song तो बीच में break नहीं हो रहा है, right? You feel that your song is continuously playing. You feel that your movie is continuously playing, but that is not actually happening in our computer. What is happening? Multiple jobs are sharing the CPU in the time sharing mode. Like you schedule song, execute 2 nanoseconds. Schedule your C language program 2 nanoseconds. Schedule your any word program 2 nanoseconds. Schedule your movie 2 nanoseconds and back to the memory. Like this, multiple jobs are sharing the CPU in the time sharing mode. Then why you will not recognize as a user you will not recognize that the switching is happening between the jobs. As a user, you will not recognize the switching is happening between the jobs. Why? Why you will not recognize? See, first, how you will recognize? What are the time I said here? 2 nanoseconds. 2 nanoseconds means what? 1 nanosecond equal to how many seconds? 10 power minus 9 seconds. How you will recognize 10 power minus 9 seconds? Is it possible? Not possible. Yes or no, right? So it means, okay, so time is very small amount of time. As a user, you will not recognize. As a user, you will not feel. You feel that all programs are executing continuously. Your song is continuously playing, but that is not going to happen. Multiple jobs are sharing the CPU in the time sharing mode. So that is called as what? Multitasking. That is called as multitasking. Right? So now we can copy this. Okay, copy this. Okay, now understand here. So that is about multitasking. Now generally, if you go for any simple interviews, maybe in your colleges, okay, maybe your teachers may confuse you like what is multi-programming, what is multitasking. Okay, your teacher may confuse you. So don't worry about all that. I will show you the complete clear difference. What is multi-programming actually, what is multitasking, okay, what is the difference between multi-programming and multitasking. I will show you in the next half an hour, maybe in the next session. Okay, I will discuss the process state diagram. So I will clearly show you the difference, what is actually multi-programming, what is actually multitasking. Okay, so don't worry about all that. So as of now, so this is enough, only these 2 points are enough. So if you want example for multitasking is what? All our operating systems nowadays whatever use, all are what? Multitasking only. Example, note down. Example is Windows, Unix and Linux. So all our popular operating systems, okay, we use, okay, so that is a multitasking only. Right. So that is a multitasking operating system. Next. Okay. So next we will move on to the next type of operating system, that is multi-processor systems. Multi-processor systems. So what is the meaning of multiprocessor? Okay, processor means what? CPU. So multiprocessor means what? More than one CPU, right? More than one CPU in a single system. So we can just copy the diagram. Diagram will be like this. Let's say CPU 1. So CPU 2. So CPU 3. So we are having common memory here. Note down, make a note of this, copy the diagram. Okay, now understand here multiprocessor system. So when you say multiprocessor system, okay, it means more than one CPU in a single system. Okay, remember this is completely different, more than one CPU in a single system. So when you are having more than one CPU in a single system, okay, we are having common memory here. Okay, it will be connected to all the CPUs and they are sharing the common memory here. Okay, more than one CPU in a single system. So that is multiprocessor system. Now just by looking at the diagram, you can understand easily one important advantage. So when you go for multiprocessor system, what is the advantages? Okay, note down advantages of multiprocessor. Advantages. So okay, the first one, understand here, when you are having more than one CPU, Okay, just listen carefully. When you are having more than one CPU in a single system, obviously what is going to be increased? Throughput of the system will increase. Is that clear? Number of jobs completed for unit time will increase. Is that clear? So when you are having more than one CPU, number of jobs completed for unit time will increase. So that is the basic advantage. Okay. So note down the first advantage: increased throughput of the system. Increased throughput of the system. Increase the throughput of the system. Okay, understand here, that's the first advantage, increase the throughput of the system. So that is the reason actually these multiprocessor systems are used in the servers. Like for example, you take any State Bank of India. Okay, State Bank of India, they have a very big database server, right? So lakhs and lakhs of transactions are happening every second. So many transactions are happening per every second, right? So they require high throughput. They require high throughput. In that case, in the like State Bank of India, in the database server, they use a multiprocessor system. Remember, for our requirement, single processor is more than enough. Okay, whatever you do, our requirement single processor enough. Remember, this is for high level systems, maybe server systems. Like you can take our Aadhaar card. Like 130 crore people are having Aadhaar card. Okay, they have very big database server, right? So much of data is stored there, and so much of fetching is happening. So many programs are happening. So they require what? High level throughput. Okay, so in that case, they use what? Multiprocessor system. Is that clear? So, advantage. I am repeating, the first major advantage is what? Increase the throughput of the system. And the second advantage, you can guess. आप लोग guess कर सकते. So, second advantage is what? Reliability. Okay, no doubt. The next second advantage is reliability. So, what is the meaning of reliability? Reliability means, if one CPU is failed, maybe because of some reason, if one CPU is failed, the system will still run with the help of remaining CPUs. Okay, maybe in our computer, let's say, multiple processors are there. If one CPU is failed, the system will still run with the help of what? Remaining CPUs. So that is called as what? Reliability. So the technical term, we call it as fault tolerant systems. Fault tolerant systems. Make a note of this. So technical term, reliability means what? Fault tolerant systems. So fault tolerant systems. Okay, tolerance means what? Okay, simple English meaning. Tolerance means what? Acceptance. Okay, right? Simple basic English meaning is what? So tolerance means acceptance. So fault tolerance system, it means what? Fault will be accepted. Simple point. Is that clear? Fault will be accepted. So it means if one CPU is failed, the system will still run with the help of what? Remaining CPUs. So that's the second advantage. And the third advantage is economical. Third advantage is what? Economical. So economical means what? Cost will be less. Okay, cost will be less. And remember, cost will be less means don't compare with our normal computer. Is that clear? Otherwise, everybody will buy multiprocessor only. Is that clear? When I say cost will be less means don't compare with our normal computer. Cost will be less means if you are buying the 3 different systems with the single CPU, or if you are buying only one system with the 3 CPUs, then cost will be less. Is that clear? Why? Because they are sharing the common memory here. They are sharing common memory, and they are sharing common maybe peripheral devices, maybe common motherboard, something like that. Okay, maybe common power cables. Is that clear? So that is the reason. That is the reason cost will be less. Is that clear? I am repeating. Okay, economical means cost will be less. Cost will be less means don't compare with our normal computer. Okay, cost will be less means if you are buying the 3 different systems with the single CPU, or if you are buying only one CPU with the one system with the 3 CPUs, the cost will be less. Okay, that's what I want to convey. Now remember, so this is multi-processor system. Okay, these are the advantages. Now generally in our laptops, most of you are having laptops. In our systems, you are having multi-core, like you are having i5 processor, maybe you are having i7 processor. What is that means? Remember, this is multi-processor. My statement is very clear. More than one CPU in a single processor, right? So let's say you are using i5 system, maybe your processor is a core i5 or something like that. i3 processor, i7 processor. What is the meaning of that? i3, i5, i7 you are having. Most of you generally computer science students, right? Generally if mechanical your friend is asking what is the meaning i5 क्या होता है भाई, i7 क्या होता है भाई, what is the answer you get? Remember, so most of the students are okay having the wrong perception. Okay, i5 मतलब 5 प्रोसेसर है, i7 मतलब 5 प्रोसेसर है, that is absolutely wrong, वो पूरा गलत है. Listen carefully, वो i3 सिस्टम भी होने दो, maybe it is i3 processor or i5 processor or i7 processor, you are having only one CPU on the motherboard. That's the first important point. Okay, listen here. Okay, so laptop में motherboard कैसे होता है? Okay, you have a motherboard like this. Okay, let's say you have a motherboard like this and you are having CPU. Intel processor will be there here. Okay, you are having processor. So this is what, okay, one CPU. So this system is different. Like this, in the same motherboard you are having 3 CPUs. Okay, one here, 3 CPUs. That is multiprocessor. Remember, in all our laptops, you are having only one CPU like this. There is no other CPU. Then what is the meaning of this? Okay, multi-core. What is the meaning of this? i7, i5, i3 and all that. Okay, listen to me carefully. Whatever may be the cores, okay, you are having only one CPU. That is the first point. What is the meaning of this i7, i5 and all this? It means some components inside the processor are multiple. No need to write anything, just listen. Okay, very easy thing, no need to write. So multi-core का मतलब क्या होता है मैं बता रहा हूँ. Some components inside the processor are multiple, because of that speed will increase. Okay, inside the CPU some components are okay multiple. Okay, what components are? Maybe ALUs may be multiple, data buses may be multiple, exactly. So that is the reason the speed will increase. Okay, थोड़ा parallel processing होगा तो speed बढ़ेगा, exactly. But remember, CPU तो सिर्फ एक ही है. You are having only one CPU. Whether it's a core i3 होने दो, i5 होने दो, i7 होने दो, okay, एक ही CPU है. So मतलब क्या है इसका? Some components inside the processor are multiple, because of that the speed will increase. What are the components? Maybe ALU, maybe data bus or something like this. Exactly. So you understand that CPU, internals of the CPU, when you study computer organization, you will understand all that. Okay, right. So okay, don't mix. Okay, multi-core is different and multi-processor is different. Okay, उसका मतलब अलग है, इसका मतलब अलग है. So okay, don't compare these two things. Right. So that is about a multiprocessor system. Okay, if you want example for multiprocessor, so popular you are having all Windows is also there and Unix is also there. So Windows, Unix. Okay, multiprocessor also we are having Windows is also there and Unix also. You can take example both of them. And the next, some students generally ask some simple questions. Generally, because we are dealing okay with last 10 years. Okay, almost more than 1 lakh students are trained from us. So general question you will have, when I say this diagram here, multiprocessor means, so students will have a simple question. The question is like this, sir, you are having multiple CPUs, CPU1, CPU2, CPU3 here. So this is all what hardware only. Okay, right? CPU1, CPU3, CPU4 is there, whatever is there. So this is all about hardware only. What is the role of operating system? यहाँ पे operating system क्या कर रहा है? Okay, that is the question students will have. Remember, important point. Whatever may be the hardware you are having in the system, in order to make use of any kind of hardware, the supported operating system is very much required. Supported operating system is very much required. So don't think like okay, multiprocessor means you are having only CPUs here. What is operating system is doing? OS is what? Software only. Operating system is a software, yes or no, right? So now understand here, when you are having multiple CPUs, okay, if you want to make use of all this, everything is managed, operated by operating system only. When you are having multiple CPUs, what is the first question comes? Whenever you are executing any job, कोई भी program को आप चला रहे हैं, okay, if you want to execute any program, the first question comes, on which CPU you want to schedule? You want to execute any program, the first question comes, which CPU you want to schedule? So who will decide that? Operating system will decide. And next important point is load balancing. Load balancing, it means what? You cannot make one CPU is always busy and this is always idle. Okay, you have to distribute the load in a proper manner. Whatever the jobs you are executing, you have to distribute them in a proper manner. So all that is managed, operated and controlled by your operating system only. So in order to make use of any kind of hardware, supported operating system is very much required. So don't look at this diagram with respect to hardware point of view. Remember, okay, obviously hardware is there, but to make use of this hardware, definitely what is required? Operating system is required. You need to change the operating system. You need to write the programs of the operating system accordingly with respect to your hardware. Is that clear? So that is the multi-processor systems. Is that clear? Right. So next, so we will move on to the next type of operating system, that is real-time systems. No doubt. Next, keep the heading real-time systems. Okay. So next is the real-time systems. What is the meaning of real-time systems? Okay, note down the definition. Note down the systems which are strict, deadly, time bound. I am writing here the systems which are strict, deadly, time bound. The systems which are strict, deadly, time bound are called as real time systems. Okay, so systems which are strict, deadly, time bound are called as real time systems. Now understand here, systems which are strict, deadly, time bound. Okay, I am writing the word called strict, deadly, time bound. What is the meaning of this? Strict, deadly, time bound means, okay, when you are executing any program, there should be no delay. There should be no delay while executing the instructions of the program. That is called as a strict, deadly, time bound. Okay, now understand here, let's say you are writing any program. Just say example, your program, let's say you are having some program P1 is there. Just say example. Okay, you are having some simple program. If you take any program will contain what? Set of instructions, right? You are writing any C language program, Java program. Okay, uske andar kya hoga? Some set of instructions, obviously. Okay, right? So like instruction I1, okay, I2, I3 and I4, like this example. Now remember, you are writing a program in such a way that every instruction should execute in the 2 nanoseconds. Every instruction should complete only in the 2 nanoseconds. So it means what? It has to complete in the 2 nanoseconds only. You are writing a program in such a way that every instruction should execute in the 2 nanoseconds. It means what? It has to complete only in the 2 nanoseconds. So there should be no delay while executing the instructions of the program. So that is called as what? Okay, strict, deadly, time bound. Okay, so that is called as what? Real time systems. Now remember, real time systems are categorized into 2 types. Okay, note down. One is hard real time and the next is soft real time. Okay, make a note of this. Real time systems are categorized into 2 types. One is hard real time and next is soft real time. Okay, so what is the meaning of hard real time and soft real time? Example, okay, just note down. Example for hard real time, okay, let's say satellite system, satellite systems, and next missile systems. Okay, and next soft real time example will be, okay, you can say banking sector. Okay, make a note of this. So hard real time, okay, so that is the satellite systems and missile systems, and next soft real time is the banking sector. Now you can imagine the satellite system. Okay, I think most of you are aware of satellite system. Generally, when you are sending the satellite onto the sky, what happens? Let's say you are having a very big satellite like this. Okay, let's say you are having a very big satellite. Okay, you are sending the satellite on the sky. What happens? I think all of you know this. After, okay, see what is the speed of the satellite. Okay, what is the speed of the satellite and in which direction the satellite should move. Direction मतलब क्या होता है? Orbit location the satellite should move. All that is programmed, operated, monitored, controlled with the software program only, right? जब okay satellite को आप भेज रहे हैं, आप कहाँ पे देखते हैं? कंप्यूटर में देखते हैं ना? Yes or no, right? So it means what is the direction it is moving, what is the speed of the satellite, everything is monitored, operated with the software program only. And next important point, what happens with the satellite system is, see, you are having satellite like this. After 10,000 kilometers, remember, this part of the satellite will detach. वो गिर जाएगा, मतलब 10,000 किलोमीटर ऐसा जाने के बाद, so this part of the okay satellite will what detach, गिर जाएगा वो. Next, after 10,000 kilometers, this will detach, and after 10,000 kilometers, this will detach, and finally, only this will remain, that will remain in the sky, and that will rotate in the orbit location, and that will send the signals onto the earth. Is that clear? So, this is exactly how the satellite mechanism works. I think most of you know about this. Now, remember, okay, after how many kilometers this part should detach? After how many kilometers this part should detach? All that is programmed with a software program only. All that is okay monitored and controlled with a software program only. Now remember, if there is a small delay, in your program, then what happens? Entire satellite will collapse. Entire satellite will collapse. And same thing was happened with the Indian satellite. Okay, I think around 3-4 years back, Indian PSLV satellite was failed. You know what is the reason it was failed? The same reason is सही time पे detached नहीं हुआ था. It was not detached from the satellite with the right time. So because of that, entire satellite collapsed. Is that clear? So okay. So what is the time? At what time it has to detach? Everything should be controlled, monitored, programmed with the software program only. With a small delay is also there. Even 1 nanosecond delay is there. So it means entire satellite will collapse. So major loss will come. And the next is what? Missile systems I am talking. Same thing is the okay missile system also. Nowadays, for example, if you are having the war with any country or whatever, so when you are operating with the missiles, what happens? You simply load the missile. And you simply select the location, distance. Okay, you simply select the location and also time. Or simply press the button, automatically missile will fire. Right, it is not nowadays you don't throw the bomb like this, right? Okay, so everything is okay machinery only, right? So you simply load the missile and you simply select the location and time and simply press the button and automatically missile will fire. Now imagine there is a delay in your program. Okay, there is a program delay is there, then what happens? आप button दबा रहे हैं, okay, missile नहीं जा रहे. Okay, you can imagine what is going to happen. Is that clear? So it means major loss will come. Okay, some major dangers will come. Is that clear? So it means the strict deadly time bound. There should be no delay while executing instructions of the program. So that is called as strict deadly time bound. Is that clear? Right. So that is about hard real time systems. And next is what? Soft real time system. Soft real time system example is what? Banking sector. Now understand here what is the difference between these two, hard real time and soft real time. The small difference is okay, in the hard real time minor delay also not accepted, but in the soft real time minor delay can be accepted. Minor delay can be accepted. Okay, इसका मतलब क्या है? Let's say in the banking sector, let's say you are drawing the money from your ATM. When you are drawing the money from your ATM, if your account is not updated, there is a 1 nanosecond delay is there. 1 nanosecond delay is there, no problem. Okay, that is fine. Okay, you are drawing the money from your ATM and 1 nanosecond delay is there in updating your account balance. So that is fine. Okay, minor delay can be accepted. Okay, but minor delay also not accepted in this case. Okay, so this is the difference between hard real time and soft real time systems. Okay, so if you want example for this okay real time systems, example for real time system is okay, just note down, that is the SX works. SX works and next VX works. So these are the operating system we use in India. Okay, in India we are having DRDO is there, ISRO is there. Okay, they use the same operating system. These are popular real-time operating systems available in the market. Popular real-time operating systems. SX works, VX works, and RTOS. This is also okay popular operating systems, real-time operating systems available in the market. Okay, right. So that is the okay types of operating systems. So in the okay introduction and background, we have covered multiple things. So first we discussed what is operating system, and the next goals of operating system and types of operating system. Okay, so actually in the continuation there are so many types of operating system available, and next client server operating system is also there, and distributed operating system is also there. Okay, but that is all not required. Okay, with respect to our syllabus, that is all not required. So simple basic understanding of this are required. Okay, So whatever the terminology I have used here, so I use in the future classes also. Like I use the terminology throughput, what is throughput, and what is the CPU time, IO time, whatever I discussed here. So I use this terminology in the future sessions. Is that clear? So that is about introduction and background, and this is not with respect to GATE syllabus, just for a common understanding, just for the freshers and all that. So I discussed all this. Is that clear? So in the next sessions we are going to enter into the actual GATE syllabus. And remember, I think you have made the proper notes for this, and remember, when you are going to solve the workbook for the introduction chapters, there are so many other things to be covered. I have not completed the total introduction. There are so many other things, like you will have something, a dual mode operation, user mode, kernel mode, and you will have the fork system call implementation, and so many other 2-3 things are there that are pending, that I will discuss in the going forward sessions. So after this class, so please leave 4 pages in your notes, leave the 4 pages, and then next session we are going to enter into the process management, that is the actual GATE syllabus. Is that clear? So ये होने के बाद 4 पेजेस आप छोड़ देना, राइट. सो मैं बताऊंगा क्लियरली क्या लिखना है, कहाँ पे लिखना है. सो व्हेन आई एम गोइंग डिस्कसिंग द वर्कबुक, आई विल डिस्कस दैट इंट्रोडक्शन टॉपिक्स, राइट. सो क्या क्या पेंडिंग है, डुअल मोड ऑपरेशन, राइट, कर्नल मोड, यूजर मोड, एंड फोर्क सिस्टम कॉल इंप्लीमेंटेशन, छोटा छोटा पॉइंट्स आएगा, वो मैं डिस्कस करूंगा. वर्कबुक जब मैं डिस्कस करूंगा वो सारे बातें बताऊंगा, आप ये 4 पेजेस जो छोड़ दिया वहां पे लिखोगे आप. Is that clear? Don't worry about your pages won't get wasted. Right. So thank you so much. So this is about introduction and background, and next we'll enter into the actual GATE syllabus. Thank you. Keep smiling, keep learning. Dear students, in the previous session we have seen introduction and background, so hope that is clear. And next we are moving on to the actual syllabus of the GATE, that is process management. And I told you that you need to give the space for the 4 pages, leave the 4 pages empty in the continuation, and next keep the heading as process management. Process management. So I follow the same contents, what is given in the first day session, same contents I follow. So in the process management, the first we'll study process concept. So let's try to understand what is process and all that. So in the process management, first we'll study process concept. So let's try to define process. How do you define the process? Definition of a process. Now understand here, the common definition and general basic definition you understand from any textbook. So how do you define the process? Process is nothing but program under execution. Program under execution is called as a process. So note down that program under execution. Program under execution is called as a process. Is called as a process. Now understand here. So this is a basic common definition. So you can easily understand. Program under execution is called as a process. So what is this means? Let us say you are writing any C language program. You are writing the C language program. Initially your program will reside in the secondary memory. Initially when you are writing the program, that will reside in the secondary memory. And when you are trying to execute your C language program, so how do you execute C language program? Normal turbo C hai, so control F9, whatever, you can press some command. And when you try to execute your program, remember that will be brought from your secondary memory to main memory. That will be brought from your secondary memory to main memory. Now remember, when I say it is a program under execution is called as a process, remember execution means the first important point, it should reside in the main memory. Note down. Make a proper notes when I am teaching. If you have any doubts, and you can just pause the video and make a proper notes. It should reside in the main memory. When you say it is under execution, the first important condition it should satisfy. It should reside in the main memory. And the next, the second thing we can say, it is occupied the CPU. Occupied the CPU to execute the instructions. To execute the instructions. It is occupied the CPU to execute the instructions. Okay, that's the second one. And the next third one, okay, we simply call it as okay, process is called as active and dynamic. Active and dynamic. Understand here. So program under execution is called as a process. Execution means the first important criteria it should follow is it should reside in the main memory. And second thing, it is occupied the CPU to execute the instructions. It means what? That is currently executing on the CPU, occupied the CPU to execute the instructions of the program. Okay. And next it is called as what? Active and dynamic. Process is generally termed as active and dynamic. What is the meaning of this? Active means okay, it is active because it is executing instructions on the CPU. Okay, it is dynamic because it is taking some input and producing some output. Okay, so that is the reason it is called as active and dynamic. And when it comes to program, what do you call for the program? Program is termed as static and passive. Program is called as a static and passive. Why? Because program is residing in what? Secondary memory only. And it is passive. Why it is passive? Because it is not taking any input and producing any output. So program is termed as static and passive, but the process is termed as what? Active and dynamic. So why it is active? Because process means it is active because it is executing instructions on the processor, on the CPU. So that is active. Dynamic means what? It is taking some input and producing okay, some output. So it is acting dynamically. It is executing dynamically. Okay. So this is the simple definition of the process. Now remember, if you take any process, process will have various attributes. Okay, no doubt. Okay, all of you copied this. Okay, next. Okay, process will have various attributes. No doubt. Next point, process will have various attributes. Process will have various attributes. Okay, so it means what? You take anything, okay, it will have some attribute. Like for example, as a human being, I am having some attributes. What is the attributes I am having? As a human being, I am having my name, I am having some height, okay, I am having some color, okay, some attributes. So same thing, okay, if you take any process will have various attributes. What attributes the process will have? Okay, so no doubt, process will have okay, attributes like process ID. Make a proper notes. Process ID, process state, okay, and next priority, and next program counter. No doubt. Okay, program counter, and next general purpose registers. Next list of open files, list of open devices, and protection information. Okay, so these are the various attributes the process is having. Okay, right. Okay, understand here, process ID, process state, priority, program counter, and all this. So what is the meaning of all this? We will understand one by one. Okay, so all of you copied this, right? Now understand here, coming to the, okay, these are the general attributes. Okay, if you take any process, if you take any operating system, generally the process will have these attributes. What is the meaning of all this? Let's try to understand one by one. Okay, make a note down, keep the heading process ID. Keep the heading process ID. No doubt. Process ID is unique identification number, assigned by the operating system. Unique identification number assigned by the operating system at the time of process creation. Okay, So now understand here, process ID is what? A unique identification number. It means what? It is just like your rule number, right? It is a unique, just like our Aadhaar card number. Okay, it is a unique only, right? Every process will have its own unique identification number. So process ID is a unique identification number assigned by the operating system at the time of process creation. It means what? Whenever you create a process, operating system will assign some unique identification number as a process ID to the processor. Is that clear? So unique means what? Simple. No two processes will have the same process ID. No two processes will have the same process ID. Is that clear? So that is the process ID. Okay, note down. Next, keep the heading process state. Process state contains, note down, process state contains current state information, current state information of a process where it is residing. Current state information of a process where it is residing. Okay, now understand here. So it means what? Okay, listen here. Process state means okay, process is going to have the various different states. Okay, that we are going to study now. Okay, after this we'll study. So process will have various states like new state, okay, ready state, running state. Okay, अगर आप already पढ़े हुआ, okay, पढ़ा है तो it means you may remember. Okay, some states. So new state, ready state, running state, and all that. So we are going to discuss all that. Okay, so in which particular state process is currently residing, that state information maintained in the process state. Okay, process अभी कौन सा state में available है, that state information maintained in the process state attribute. Okay, so that is about process state. Okay, no doubt. Next, keep the heading priority. Priority is the parameter. Priority is a parameter assigned by the operating system. Priority is a parameter assigned by the operating system at the time of process creation. At the time of process creation. Okay. So what is priority? Simple, understand here. Priority is a parameter. Okay, क्या लिखे थे? Priority is a parameter. Parameter in the sense what? Some number. Okay, some number. Example. Okay, let's say priority of a process is okay 2, priority of process is 9, priority of process is 1. Okay, 7. Some number. Okay. So operating system will assign some number. Okay, some parameter as a priority to the processor. So what is the purpose of this priority? What is the purpose of this priority and how that priority will be used, that you will understand when we discuss the CPU scheduling. Okay, when we discuss the CPU scheduling, you will understand what is the purpose of priority. Okay, right. So that is about priority. Okay, as of now, just remember priority just like a number, some number will be assigned. Okay, what is the purpose of this, you will understand when we discuss CPU scheduling. Okay, next, note down, next is a program counter. Program counter. Note down, program counter contains address of the next instruction. Program counter contains address of the next instruction to be executed. Program counter contains address of the next instruction to be executed. Okay, understand this. Okay, if you are already studied computer organization, I think you might be knowing this, but those are studying first time, okay, listen here. What is the meaning of program counter? Understand this. Program counter contains what you have written, address of the next instruction to be executed. Like for example, listen carefully, you are having some process. Let us say you are having some process. Okay, now if you take any process, let's say process P1 is there. If you take any process will have what? Set of instructions. Okay, simple. Anything your program without set of instructions only, right? So process will have set of instructions. Okay, let's say I1, I2, I3, I4. And remember, every instruction will have its own address. Okay, because when it is residing in the memory, main memory, okay, every instruction will have its own address. Like for example, instruction I1, okay, that is 10, address 10, I2, present address 20, let's say address 30, okay, let's say address 40. And remember, okay, listen carefully, when you are executing this process, let us say for example round robin scheduling. Okay, if you don't know round robin scheduling, let us say every process will be given time period of 2 nanoseconds. In the yesterday class I told you in the multitasking, for every process you give some amount of time, right? So let us say we are giving 2 nanoseconds of time. Imagine this process may have 4 instructions and this process may have 400 instructions and it may have 4 lakh instructions depending on the program, number of lines you are writing, okay, how big is your program. This program may have 4 instructions or 4 lakh instructions. Remember how much time you are giving to this process here? Only 2 nanoseconds. Let's say you are having round robin scheduling, the time quantum is 2 nanoseconds. Let's say you are giving 2 nanoseconds of time. It means, okay, this may be having any number of instructions, but you will give only 2 nanoseconds. Remember, in the 2 nanoseconds of time, there is no guarantee that it will complete all these 4 instructions. Yes or no, right? In the 2 nanoseconds, there is no guarantee that it will complete all the 4 instructions. It may have 400 instructions, 4 lakh instructions. Now imagine, it is executed only 2 instructions. It is executed 2 instructions. Now the 2 nanoseconds is completed. Now what happens? Now this program will be removed from the CPU and it will go back to what? Main memory. Yes or no, right? So now remember the next time, listen carefully, now 2 nanoseconds is completed, it will remove out of the CPU, okay, right? You are going to schedule another process. Now remember, okay, वापस दोबारा इसको कभी ना कभी तो चलाना ही चलाना है. Okay, again you have to schedule the process P1 to complete the remaining instructions. Yes or no, right? So obviously you have to schedule again the process P1 to complete the remaining instructions. Remember, next time when the P1 is again scheduled onto the CPU, from which instruction you have to execute? From which instruction you have to execute? That is identified by the program counter. So it means the program counter will assigned with the address of the, what you have written, address of the next instruction to be executed. So what is the next instruction of address? Address क्या है? 30. So program counter will be assigned with what? Address of 30 here. Is that clear? It means what? Next time when the P1 is again scheduled onto CPU, okay, CPU को कैसा पता चलेगा? How CPU will recognize which instruction it has to execute? It will recognize with the help of what? Program counter. Program counter will contain address of what? Next instruction to be executed. Okay, so what the CPU will do next time when you schedule this process, it will simply check the address what is there in the program counter, what is the address it is having, 30. Okay, it will simply go to that particular location and it will fetch that instruction and it will execute that instruction. So once it is completed, again program counter will change to what? Next instruction. Let's say that is 40. It will execute like this, instruction by instruction it will execute. Is that clear? So that is the meaning of a program counter. Is that clear? So that is about the program counter. Next, so remaining things no need to copy, just listen. Okay, so because they are simple, okay, no need to write all that. Okay, if you want we can make the rough notes, otherwise not required. So next is what here? General purpose registers. What is the meaning of this? Remember, in order to complete execution of any process, obviously internally it will make use of some registers. If you want to execute any instructions, internally it will make use of some registers. You have some general purpose registers. Okay, I think if you studied already computer organization, they will clearly explain what is general purpose registers and all that. Okay, so in order to complete any process, okay, execute any process, that requires some registers. What are the registers? What are the registers currently used by the process that is identified, that is maintained in the general purpose registers attribute? Is that clear? Right. So next is what? List of open files. It means what? In this you maintain, in this attribute you maintain what are the files currently used by the process. That information you maintain in the list of open files attribute. Like for example, okay, you are writing, yesterday I told you in the previous session, okay, let's say you are writing a file programming. File programming में क्या लिखते हैं आप? Okay, you write f open, f close. In the f open you give the name of the file and in which mode you are opening the file. Okay, if you are writing C file program in the C language, you might be knowing all this. So in case, it means what? Your program is reading the file from that particular, okay, program is reading that particular file from the hard disk. It means it is using that file. So what are the files currently used by the process? What are the files currently used by the process? That files information maintained in the list of open files attribute. And the next is what? List of open devices. It means what? What are the devices currently used by the process? Like currently your process is using, okay, let's say, okay, printer को use कर रहा है. So you maintain that printer ID will be maintained here. agar okay your process is using currently okay for example okay scanner, it will maintain scanner ID will be there. So every device will have its own ID obviously, okay, just like that. So what are the devices currently used by the process, that proper information maintained in the list of open devices attribute. And the next is what, protection information. Protection information means what, obviously okay for the protection purpose operating system will provide some kind of attributes, some kind of algorithm internally, okay, right, for the protection of the processes. In case if it is using any algorithm internally for the protection of the process, that related information okay uska koi okay encryption in okay decryption aisa kuch information hai, so that will be maintained in the protection information attribute. So these are the general attributes the process is having, okay. So if you take any operating system, so these are the general attributes, okay, every operating system will definitely have. But remember, depending on the operating system to operating system, you may have some additional attributes also. Like for example, Windows may have some any additional attribute, or Unix may have any additional attribute. If you write your own operating system, if you design your own operating system, you can include your own attribute. That is also possible, right? It is just like a software program only, right? Okay. So okay, now going forward, okay, slowly I will introduce some more attributes also. So now it is not required, okay, because when I discuss memory management and when I enter into paging, I will add one more attribute, okay. So I feel it is not relevant now to introduce that attribute, so I am not discussing that. So these are the general attributes every operating system will definitely have, okay, right. Next, note down the next important point. Now remember, all the attributes of the process, listen here, all the attributes of the process is called as context of the process. All the attributes of the process is called as a context of the process. Note down next point. All the attributes of the process is called as a context of the process. Okay, so all the attributes is called as a context of the process. Okay, so going forward, I will use the word called context. So whenever I say context, you need to understand I am referring to what, attributes. Okay, so all the attributes of the process is called as a context of the process. So whenever I say context, you need to understand I am referring to attributes of the process. Now remember, context of the process will be stored in the PCB, process control block. Note down next point, context of the process will be stored in the PCB, that is a process control block. Context of the process will be stored in the PCB, that is a process control block. Okay, so all the context will be stored in the PCB. So PCB will look like this. Okay, all the attributes we are going to store. So copy this also. You maintain all the attributes in the PCB. So PCB will look like this, like process ID, process state, priority, program counter, general purpose registers, list of open files, list of open devices, protection information. So this is a PCB. So PCB will look like this, and you maintain all the attributes in this. Copy this, right. So all the attributes is called as a context, and context will be stored in the PCB, and PCB will look like this. And remember next point, every process will have its own PCB. हर प्रोसेस का अपना अपना PCB होगा. Every process will have its own PCB. Note down next point. Every process will have its own PCB. Every process will have its own PCB. And next, now remember, PCBs of the processes will be stored in the main memory. ओके पूरा एट्रीब्यूट्स इसमें रहेगा, पीसीबी में रहेगा, और पीसीबी कहाँ पे स्टोर रहेगा, मेन मेमोरी में रहेगा. ओके नोट डाउन नेक्स्ट पॉइंट, PCBs of the processes will be stored in the main memory. PCBs of the process will be stored in the main memory. Okay, right. Next remember, PCBs will be implemented. The data structure used to implement the PCBs is a linked list, double linked list. Okay, PCBs will be implemented by using double linked list. No doubt. Next point, PCBs will be implemented by using double linked list. Okay, now understand here. Okay, don't confuse why the linked list is used. Okay, I think if you study data structure, you will understand what is linked list and all that. Remember, you cannot use array. The problem with the array is array follows a static memory allocation. Okay, we need to define the size of the array prior to the declaration, right? But the linked list size is dynamically we can grow the size of the linked list. Okay, in case if I come up with the data structure course, then I will discuss all that in detail, what is linked list and how we can implement and all that. But as of now, the basic understanding, okay, right, the linked list, okay, size will be, you can grow dynamically. Okay, so that is the reason the data structure used to implement the PCBs is what? Linked list, double linked list. Okay, right. Okay, just remember, don't worry, okay, about this point too much, just remember this point, that's all. Okay, so I am coming up with all the points. Okay, I am revising all the points. Listen here. Okay, process is having various attributes, and all the attributes is called as what? Context of the process, and context will be stored in the PCB. And remember, every process will have its own PCB, and PCBs will be stored in the main memory, and PCBs will be implemented by using double linked list. Is that clear? All the points are clear, right? So that is about attributes of the process. Next, okay, note down the next one. Process will have various different states. Note down next point. Process will have note down next point. Process will have various different states. Okay. So process will have various different states. What are the states the process will have? Okay, note down the new state, next ready state, running state, next wait or block state, termination or completion state, and next suspend ready state, suspend ready, and next suspend block, or you say suspend wait. Okay, so these are the various states the process is having. Okay, right. So I am repeating. So when you take any process will have various states like this: new state, ready state, running state, wait or block, termination or completion, suspend ready, suspend block or suspend wait. Okay, so what is the meaning of each and every state, and how the process will move from one state to other state in the life cycle execution of a process? Okay, how the process will move from one state to other state in the life cycle execution of a process. What is the meaning of life cycle? Life cycle means from process creation to process termination. Okay, so what activities it will perform and how the process will move from one state to other state, that we are going to study in detail. Next we are going to study in the next 10 minutes. We will start the process state diagram. We will understand all the states. Okay, right. So just remember all that. We will discuss later. Next, if you take any process, the various operations will be performed on the process. If you take any process, we perform various operations. So what operations you perform? Note down various operations performed on the process. Various operations performed on the process. So let's say, what are the operations you perform? Creating the process, okay, scheduling the process, dispatching and execution, next termination termination, or it is also called as killing the process. Okay, and next suspending the process, and next resuming the process.